Okay, so this semester, the definition of derivative does not appear on the second exam, so you don't need to worry about this problem. So the definition of derivative is not on second exam in the fall 2018 semester. Okay. Number 3 says the linear function L is tangent to the graph of 1 over x at some point in the first quadrant. Suppose the slope of L is -2. Find the point and determine the x-intercept of L. Okay, so first of all, I'll just draw a graph so that we can kind of see what we're doing. The graph of 1 over x looks like this. And so then there's some point where this function is tangent. And we get some line like this. So this line in blue is the line L. And then this graph of 1 over x. Okay. And so we know that the slope is -2. All right. I also know the slope of a tangent line is the same thing as the derivative. So what is f of x? I can write as x to the -1, and then I can take the derivative. F prime of x is equal to -x to the -2. And so if the slope is -2, that means that that's equal to the derivative. Okay, so that means that x to the -2 is equal to 2. And so I can write this as 1 over x squared is equal to 2. So I can move the x squared over, divide by the 2, and I'll get 1/2 is equal to x squared. So x is equal to 1 over the square root of 2, or the square root of 1/2. And so that is the x value at the point of tangency. I'll just write it this way, square root of 1/2. Okay, and so then I want to find this x-intercept. So I can clearly see that it's going to be further to the right than square root of 1/2. So let's, so I found the c, so that's my point c, is square root of 1/2. And then I can find f of c. So f of square root of 1/2, well, what does f do? F flips things over, so it's just going to be square root of 2 over 1. So that's the y value here at this point. Okay. And then I can determine the x-intercept of the line. So let's write down an equation of the line. So I'll have y minus y1 equals m times x minus x1. I have that. And so at the x-intercept, that's when y equals 0. So if I plug in 0 for y, then I can solve for the x-intercept. X minus, I'm just going to write this as 1 over square root of 2 because it's the same thing. So then I can divide by -2. So I get square root of 2 over 2 equals x minus 1 over square root of 2. And then I can add 1 over square root of 2 to the other side, or add it over. And if I add those two, I get, let's see, let's get a common denominator here. So that's multiplied by square root of 2 over square root of 2, and that gives me x is equal to square root of 2 over 2 plus square root of 2 over 2. If I add that, that's 2 square roots of 2 over 2, which is square root of 2. So that goes here. And that's the x-intercept. All right, on this one, we want to label everything. Okay, so the first thing here is the expression for h is this distance between a and a plus h. So this distance here is h. So that's quantity e on the graph. Okay, f of a is the y value for the point A. So if I go up here to A, I can see that f of A is B. Okay. Oh, whoops. I think I did that wrong, because f is the function up here, right? The function f is this guy. So f of A is actually not that one. It is... I need to go all the way up to the function. I didn't go all the way up. So if I go all the way up to the function, I get here, and it's A. So that's actually A. F of A plus H. So if I go to A plus H, and I go up to the function f, this curved line, and I go over the y value at A plus H is B. There we go. And f of A plus H minus f of A, that's going to be this distance between those two y values. And that is labeled f. F of A plus H minus f of A over H. That's going to be the slope between this point and that point. So the slope of that line, and that is labeled D. And then this one is the derivative, which I'm going to erase all this stuff because it's getting kind of crazy over here. So that's the slope of the tangent line to the graph. So there's the thing, and so I need to draw that tangent line. The slope of that is the value of this thing. And so I can see that that is labeled C. And we're all done.